Okay, so let's do 8.5 number 34, which has parts A through, I don't know, like K or something.
I.
I letters in the alphabet. Okay, so what's part A? Where's the, what? Vertex. That's what the instructions on this section say. It doesn't really matter.
The vertex.
Is the confusion there that I listed them in a different order than the book does?
Maybe.
Okay, I think that's probably true. The first time I wrote this whole rigmarole down, I probably just threw them up at random, and the book always uses this one order. So it doesn't matter, right? You just need to know how to do each thing. So to find the vertex, what do I do?
You identify your A and B.
Yeah, I could identify C too, but I don't really need to, right?
Yeah.
So I want to look at this thing and I want to think about A, B, and that's it. I don't care about C. So what are A and B?
Negative 1 and 1.
Negative 1 and 1. Is everybody playing along with that?
Yeah.
Yep.
Okay. All right, so we got negative 1 and 1, and our vertex, when we see the word vertex, we think to ourselves, x equals
Negative b over 2a.
perfect.
Yeah.
That was the one thing we needed to know out of 8.4, right? Okay, so if the vertex is at negative b over 2a, then the vertex on this thing is at x equals
Negative 1 over 2 times negative 1.
negative 1 over 2 times negative 1.
Yeah.
Good, which is 1/2. Okay?
Okay.
A vertex, though, should be a point categorically, and what I have here is, yeah, I have half a point. Where do I get the other half?
You plug it in for x.
I take this and plug it in x here. Why?
So you can find the y coordinate.
Correct.
Because
Y doesn't x equal that.
Well, you have x.
'Cause you have half of the-
y, so the other half of the point, I guess, the coordinate.
yeah, so this is a point on the graph, right? So it's an x comma
F of x.
f of x pair, right? So if the x is a half, then this other point had better be f of a half. You guys with me on that?
Mm-hmm.
All right, so this should be f of 1/2, which is minus a quarter
Plus a half.
plus a half
Plus 20.
plus 20.
Right.
And just
Playing along, or did I lose you? Good. Totally lost. Okay, so what I'm trying to do is I got this vertex out of identifying A and B, right? I just applied the formula from 8.4. So I found the vertex. That was at x is a half. But a vertex is a point, not an x value. So I need the second half of that point, which should be f of a half. So I took this x, and I crammed it in for the x's up here. So really, maybe I could look at this thing and I could think to myself, this is minus 1/2 times 1/2 plus 1/2 plus 20. Is that better, guys? Okay, so when I multiply a half times a half, I get a quarter, and then the negative. And then this is just chilling, that's just chilling. So then I want to think to myself, can I simplify this? Do you do any better than this?
yeah.
Combine like terms in the
Okay, we can combine like terms. What are like terms here?
So you'd have to find a common bottom first.
Cool, let's find a common bottom. So the common bottom here is going to be in quarters. So I've got negative a quarter, that one's good, right? How many quarters is a half?
2.
2 quarters. So I've got negative a quarter plus 2 quarters plus, how many?
85. 4.
8. Cool. I'm like an 80. Right, and if you need to on these, think to yourself, how am I getting there, right? So if you need to, you might think about this 2 quarters. You might think that's a half times 2 on the top and 2 on the bottom.
Why are we multiplying it by 2?
I'm multiplying it by 2 on the top and bottom to get the bottom to be 4, so I can count these all as quarters. This is like you've got some whole pizzas and some quarter pizzas, and you want to count the whole thing as quarter pizzas, so you take your whole pizzas and cut them up.
Okay.
This is just me cutting a half into 2 pieces each, so that I can count it as quarters. This is me taking whole things, 20 whole things, and cutting them into 4 pieces each.
Okay.
You guys all see that? Okay, so all told, how many quarters have I got here? 81 quarters. Can I simplify that at all? No, probably not. Okay, so my vertex, it looks like, is where?
1/2 and comma 81 over 4.
Okay, that was a lot of arithmetic to get
Pretty sure this is the one we were working on.
a vertex, right?
Because I remember that 81 there.
Okay, part B should be easier, I think, because I believe for this problem it's up or down.
Now it's finding the x and y coordinate.
What? Isn't that C and D?
Yeah, that's CD.
What is it?
No, B is the upward or downward.
C. I've done
Yeah.
4 of
Yeah.
these.
This is the one we did.
So, on part B, I'm wondering, does the graph open up or down?
Down.
Down.
Is that just because I drew this over here?
No, it's because there's a negative.
Okay, good. So I'm looking for A, and I'm wondering, is A positive or negative? In this case, it's negative, so down. That one was easy. All right, C and D are x-intercepts and y-intercepts.
Correct.
Okay, so which one's which?
C is X.
No, I mean which.
Oh.
Like the
How do you find them?
0 is Y.
Plug in 0 and F of 0.
Yeah, so I need to figure out when is F 0 and what happens when I plug 0 in, right?
For 0.
Yeah, plugging 0 in makes me on the y-axis, so that's the y-intercept. So what do you get when you plug 0 into F?
20.
20. So this is F of 0, this is 20. And if you wanted to, you could express this as a point. What would the point be?
0 and 20.
Yeah, it would be 0, comma 20. Okay, see that? Why is that kind of redundant?
Because you're already saying that 1.
We're just asking for the y-intercept.
Yeah, because when I'm telling you the y-intercept, the x value is going to be 0. I recommend that you write the green thing if you're having a slight tendency to, mix these, so that it's clear at least what you're thinking. Good. So if you're comfy with the x-intercept and the y-intercept and that you're getting them right, just listing the numbers fine. But if you're not sure whether you've got the x or the y-intercept, I would recommend you list them as a point, so that at least it's a little more obvious that you know what you're doing. How about x-intercepts? What do I do with those?
Set the equation to 0.
Okay, so I should set the equation equal to 0. So I'm looking for 0 equals minus x squared plus x plus 20. Subtract 20. Why? What's your plan? I'm not saying you're wrong. I just want to know what your plan is.
So we have the x's on one side. I guess we could just leave it in that form and plug it into the quadratic, or we just have to get it down at 1.
Or you could probably AC factor it, which would be a lot easier.
Do you need to go full-blown AC on this thing?
No, you don't
Probably
have
just
to do that.
factor it.
We could almost just factor this, except that there's this really annoying negative sign, right?
You divide it.
Multiply the whole thing.
multiply by -1, and it's Lauren, right? And Lauren wants to divide by -1.
You can do either one. Want to go outside and beat each other with sticks, and whoever wants to be the winner, we do.
Okay, you probably don't need to threaten her. Thank you. Why is the threatening unnecessary?
Because you can do either or. It doesn't matter.
Yeah, because they're both the same thing. You guys see that?
Dang.
Dividing and multiplying by -1 are the same thing. So really this step could read, flip the sign. I'm going to write it as multiply by -1, but divide by -1 is also fine. So you get 0 is x squared minus x minus 20. Okay, now this I would probably argue for factoring. Okay, see that? Cram it in quadratic formula is also fine. The thing I would suggest that you not do with this is,
Complete the square.
yeah, I probably wouldn't complete the square. Why?
Because you have an odd number on your b value.
Yeah, your b is odd, so it would be inconvenient.
Why?
So I'm looking for how to factor this. You guys remember how to factor? I'm looking for two numbers that multiply to 20 and add to -1. Yeah, it looks like -5 plus 4. Okay, what do you do with those?
Parentheses.
Like this?
The X.
And then x's?
Yep.
Hey, cool. Then I should probably spend just like half a second multiplying this back out to check to see if you got the right thing. So there we go. We're good. Now what?
You set them both to 0. Yeah.
What are you applying?
0 product rule.
Cool. So we should zipper this and get x is 5 or x is -4.
Yep.
Does all see that, or do I need to go back?
-5, 4.
How about x minus 5 is 0 or x plus 4 is 0? So if these two things multiply to 0, then this thing's 0 or that thing's 0, right? So either x minus 5 is 0 or x plus 4 is.
Okay.
Then you need to subtract 4 from this one to get the x by itself. So you'll get x is -4. And on this one you need to add 5. So the signs are always opposite from what appears here.
Okay.
And you can either do both these steps or jump to the end, I don't care which. Wait, what were those? Why did I just circle that? Because it felt like I was done, right? So those are my x-intercepts. So I should write x-intercepts are
-4,
5, -4. I would be really super careful with this. That looks like a point, right?
5.
5 and -4. Or 5 comma 0, -4 comma 0. Something like that.
5,
Or
really.
x is equal to 5,
Yeah.
or x is equal to -4.
Yeah, or actually that thing. Yeah, yeah.
Yeah.
Absolutely. Okay, what else could I do? What else is the next one?
E, which is determine the domain of this function.
Okay, so now we get to the things that you actually wanted to know about.
Yeah.
Cool. All right, so E, domain. Why?
Because it's the it's every number.
Yeah, it's a U-shaped thing. I know how to fit all the numbers into this rule.
Okay.
Like all of the operations that I have to do in here, I have to square numbers. I have to multiply by -1, I have to add them, and then I have to add 20. I'm not running into any problems with those. The things I should look for are maybe like, I don't know how to divide by 0.
Right.
So if I was dividing by something, I would be like, oh wait, can that thing be 0? If I was square rooting something, I might worry if that thing inside were negative. But here I'm not doing anything that's that could lead to problems.
So is the domain always all real numbers?
For a parabola, yeah.
Or parabola?
For a parabola, yes.
Okay.
Yeah. So one thing we could do is we could kind of look at our sort of half-assed picture over here,
Yeah.
right? It's a U shape that's pointed downward. If I smash it this way, right, onto the domain, I'm going to get all the real numbers. The range gets a little bit more complicated. Why?
Because it stops at the vertex.
Oh yeah, there's a vertex and an up or down consideration. You guys all see that?
Yeah.
So this one pointed
Down.
down. So where's the range start?
Negative.
Negative infinity?
Why not 0?
Why not 0?
You have numbers smaller than 0 in the range.
Yeah, I have numbers more negative than 0 in the range, as kind of indicated by whoop, that arrow goes down for good, right? You guys cool with that? And actually both arrows go down for good. So I'm going to cover everything that's really negative twice. Once way over here and once way over there. All right, so we start at negative infinity. I'll put the bracket on that for you. And where do we go? What are you talking about?
1/2.
Isn't that the y coordinate of the vertex?
I don't know. Convince me.
That's the max you can go.
Convince me.
Yeah,
Like that's the top
the
of the
vertex is the top of the parabola, right? Yeah, so you're absolutely correct. If I smash this way, right, the highest thing I'm ever going to get is the top of the parabola. And I know where the top of the parabola happens. It happens at
81/4.
Okay.
It happens at a half,
Right.
which is x information, and I'm going to smush out, right?
Right.
And a y information piece that I'm going to keep.
Okay.
So it goes to, oops, not the right symbol.
That makes sense.
That is supposed to go this way. And is that open or closed?
Close.
You're including them?
Yeah.
Isn't it open because it's,
Oh, yeah.
it's that point where it's transition?
No, it's close. Other one. That's the.
That's for increasing, decreasing. So this one's closed because I'm asking a question about ranges, right?
Okay.
So I'm asking, is there an input that gives you the output 81 quarters?
Because it stops exactly at that point.
Yeah, and there sure is an input that gives you that. It's this one. You guys see that? Like, I'm sure on that one at least there's an input that gives you that because I know what that input is. All right, let's see. So G is positive. X values for which the function is positive.
Correct.
So what do they mean? When is the function positive?
When it hits 0, essentially. Well, not exactly, but.
Is 0 and above?
Yeah, when is it above 0, right? So someplace there's a x-axis, right? And then there's like stuff that's above the x-axis and stuff that's below it. You guys see that? So this stuff here would be the stuff that's above, right? So I'm asking, for which x values does that happen? And this is actually easier than you're probably thinking right now. What are these?
Negative or negative
The
4.
x-intercepts.
Yeah, those are the x-intercepts. They're at negative 4 and 5, right? Okay, so this thing's positive.
Anywhere between negative 4 and 5.
Yeah, between negative 4 to 5. So negative 4 to 5, and what brackets?
Open.
Closed. Those are included.
Depends. Do you count 0 as positive or negative?
Count it
This
as
class
both.
we did.
Yeah, we were counting as both, so we'd put closed brackets on these. Specifically because 0 is positive, right? Okay, so H is x values for
Negative.
f of x negative. What should that be?
Everything below 0?
Everything.
Or everything at 0 and below?
2, 4.
Yeah, so I'm looking for everything that gives me an output below the x-axis, right?
everything up to -4 and everything after 5.
You guys all see that? It's all the other stuff, right? These are the x's that give you positive things. So the x's that give you negative things should be everything else. Except maybe the ones that give you 0, right? Because you have to make this decision. So we should start at -infinity and go to -4. And then also from 5 onwards. And what kind of brackets do you put on the -4 and the 5?
Well, it's because your zeros
You're counting zeros and negative as well.
Yeah, and again, I think that's a little different than your book.
It is.
It's not a distinction that matters. Part I is decreasing.
Right.
Totally backwards. Okay, cool.
Yeah, it is.
So they're asking which x values for x decreasing. This is a really poor sentence that I'm constructing here. Really, they mean which x values is the function decreasing for, or something.
1/2 to infinity.
Oh, how'd you figure that out?
Because that's where the vertex is on
That's when you start.
Yeah, so, okay, we're looking here, right?
Right.
So I've got this kind of a picture. My guy walking along from left to right, and I'm wondering, when is he walking? Decreasing is downhill. Okay, so when is this guy walking downhill?
after the vertex.
Yeah, after the vertex. And then I only care about the x values, right? Because they asked me only for x values. So where's the vertex in x terms?
1/2.
1/2. Cool. So I go from 1/2 to
Infinity.
infinity. That one's an open bracket.
And then 1/2 is an open bracket because you're transitioning.
Yeah, perfect. Yeah, that 1/2 doesn't really make sense as increasing because, or decreasing, because on the left of it it's increasing and on the right it's decreasing. So I don't know what the heck that is. Some kind of funny local flat spot. Not big enough to stand on though, kind of strangely. So this would be x values for f of x increasing.
Yeah.
Negative infinity to 1/2.
Oh, cool. The other stuff, right?
Open parentheses.
And again, open. You guys cool with this? It should be noted that it would also make sense here to ask x values for f of x constant, right? The flat ones. And then what would you write?
1/2.
Maybe a half, I don't know, right? Because there is kind of a flat spot there, but it's kind of weird. Your book doesn't ask about that really. I want you to think about that a little bit because it's nice and it's cool math. It has a nice physical interpretation too, that flat spot. When you throw something up in the air, what's that flat spot read as?
Where it stops moving entirely.
Yeah, it's the dead point. You guys know that term? Climbers like to use it because when you jump for something, it's the point at which you want to latch. You want to hit things at the dead point so that you're not moving. You can just, okay, fine, do that way. Questions on this? Anything else?
What was that sound effect again?
Everyone's all,
Me?
no.
What happens when you latch when you miss?
Then you fall.